Yo, let's start today's stream. So, once again, I'm just gonna pick up where we left off, and a large part of yesterday's stream was fighting with the normal generation of the terrain. So, initially, we relied on Unity's mesh.recalculate normals, which works very good. But if we want to do this with terrain patches, we want to do this normal generation ourselves so we can handle these edges properly. So we implemented a few approaches to the normals. Good morning, Harukanan. First off, the simple one, basing the normals of up and down gradient. Let me open up GIMP as well so we can draw some things here. So the most simple approach is welcome back, Harukanan, and good morning. So is the FRA ad growing on you, or do you like it even less these days? Okay, so the first approach for the normals was to do this and do the cross product between those. The second approach we have is this again, but this one and this one as well. So you take this one and this one, do the cross product, and you take this one and this one and do the cross product, and you get a little bit of a better normal. The last approach, which we noticed was the same as Unity's, is the just working with let's see here, just working with connected vertices. So for this setup, that means this, 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 and this. And we noticed that by doing this, doing cross product, adding it all together, we got the same result as Unity. Yeah, starting to love that rage feeling I get every time I that little extra boost of energy from rage adrenaline. I know that feeling. So if we do that, so we take those 6 neighbors, we do the cross products, and we add them like this, then we get the exact same result as Unity. One user on Stack Overflow said that this can be simplified to this. I had a hard time getting to that conclusion on yesterday's stream, and that's pretty much where we left off, because we tried his simplification, and with some minor adjustments it gave the exact same result except for the normals at the edges, and that's where we were trying to fix yesterday. Watched Marvel's Avengers yesterday, and Bruce Banner is 100% me. I get the point of that, but like Avengers references like fly above my head. But what did you think about the movie? So is Bruce Banner some Hulk related character? But, so after yesterday's stream, I actually took the time to simplify this, try and simplify it, and I actually ended up at this one. So I'm just gonna write this down in the GitHub issue, because I think we're gonna move on with this little artifact at the edges, because I think it has to do with this. Bruce Banner is Hulk, yes. Yeah, I'm so bad at Avengers and Marvel references, unfortunately. Never been my cup of tea. But okay, Bruce Banner is Hulk. Okay, now I get it. Is Spider-Man Marvel? Because... okay, what... my favorite, if so, my favorite Marvel movie is Spider-Man Into the Spider-Verse. Jesus Christ, that movie was good! Such a beautiful piece of art as well. Oh, the first Iron Man I actually saw. I saw it when it was in the cinema, so to speak. It was pretty good. Then I watched the first Avengers, I think, when I was a little bit older, and it just... I did not enjoy it. Okay, so notes, thoughts. Ooh, I would like to name this notes as well, but I don't want a subcategory under a category notes that is also notes. But let's call it implementation notes. Normal calculation. So I just want to simplify this so this makes sense. and want to have it in notes. The question is though, markdown math symbols. Do we have anything math support in? Oh. Damn, this is nice. And then you go like LaTeX or whatever the name for it is. A not equal. This is beautiful. Do I want to do this? Yes, I do. I want to have this calculating the normal. Let's try if it works first. N. Oh my god, it does. Okay, so this is what we're gonna start today's stream with. Some mathematics write down. So calculating the normal N. Actually, can we do lower as well? Calculate NP for point P. Using its connected neighbors. Do I want to state that? I wonder if I want to do. Can we do left? Up. Right. Down. Upright. Let's call it UR. And down left. I want to see how this looks. And down left is done. Oops. Is done with the following calculation. And then we want to do Actually, let's do it like this. It's done with the following calculation. L, is it backslash, I forgot, cross, up, let's see. Okay, that's not it. Thought it was. Okay, so let's see. Markdown, math, cross product. I guess this is that they are using this syntax. Yeah. Times. Okay, yeah. I'm still not entirely used to cross being named as times. Beautiful. So, left times up plus, we want to keep, plus up times, what is it, right plus right times down plus, oh, have I gone, let's see here. This is left times up, up times, no, up times upright, and then upright times right, right times down, down times down left, and down left times down. Look at this. Big fan of being able to use like LaTeX mathematics syntax in README files. That's beautiful on GitHub. But this doesn't look that clear, I don't think. So we're gonna do beautiful, and then we want to normalize this one. Dot. Do we want to keep? Oh, normalize. How do you do normalize in math? Tesh normalize. Isn't that actually just 2 lines like this? Yeah, I think. And then of course, being proper with the math, we want to do NP, come on, is equal to. Wow, beautiful. Good morning, Roguebit. I'm doing fine, thank you for asking. How about you? How are you doing this, what is it, Tuesday morning? And I'm just, before I continue with this math stuff here, I just want to say sorry, but we're gonna start this stream extremely boring, according to some, but like the majority of yesterday's stream was normal calculation for based on height maps. and I just want to get the approach we took down on paper and the simplification so that I can reference it later on and so that I don't forget it. What's up, E-Dragon? But this, oh, I like this so much. This looks beautiful. So here comes the simplification, which can be simplified using delta. Can we do this? X, Y. Where this brings me back writing stuff like this. Beautiful. D X is the distance, horizontal step distance between points. Let's see here. Points, and the Y is the vertical step distance between points, which can be simplified using, and then we need a where 2, maybe not the clearest, but whatever. Okay, you can't highlight this one, but okay. And this is where the magic comes. So actually, do I want to calculate a normal NP for point P is equal to Y Z? Yeah, let's do it like that. X, Y, Z. Okay. So this is where you can simplify it extremely nice. So here we have 6 different points basically. L, U, UR, R, D, DL. And just doing this and trying to simplify this, you can't really do that. Good morning, Fabic. How are you doing today? Instead, you need to replace these points first, or you need to substitute them with another way to express them. And that is, so N, the normal for the point. Actually, is this, can I make this a little bit bigger so it's maybe a little bit more visible on stream? So we want to simplify this. And I think we can skip the parentheses now. Just woke up. Oh, nice. Starting off today with some math here. I'm pretty fine as well. I feel energized and ready to tackle this problem today. Or it's not really a problem anymore, but tackle the next problems in line at least. So the idea is to simplify L. We want to write L with the notation of the point using the step distance between points. So the left point, instead of writing L, you can actually write it using X, Y, Z with an offset. So it's left is X minus D X Y, and then we do said L here, because the said, no, not said actually, but why L in our case, because that's our height. So how does that look? Oh no, I forgot this one. X minus dx yl wasn't too pretty said. I think we want to do it like this. Did you manage to solve the normal problem? Yes, or like I managed to get to the bottom of it, and that's what we're doing here. I'm gonna, for future me, I'm gonna put down how we calculated the normals, because the issue right at the edges is still gonna be there, except if we find another approach. And the simplification here is going to show why that is the case. So yeah, if we rewrite this one using this logic for all of it, it's going to look something like, yeah, I'm gonna do this. So we do up then is x, y, u, z plus d, y. And then we do a plus here, and we continue. I'm still curious about that 6 is that 6 in y. Yes, I'm gonna show you why we get 6 in y. Definitely. I got to the bottom of the problem yesterday, and it was a nice feeling. So what do we have? We have up again, times, and here we want to do UR, so that's x, so upright x d x, and this is upright, so we want to do y upright, and then we do plus. Yeah, I know that wasn't the best misspeak, whatever is the English word for misspeak, missaying, but yeah, slip of the tongue. Freudian slip. Okay, let's see. I think this is correct. And then we want to do this one again. Come on. Times, and what do we have then? UR times R, which is x plus dx, y, what was it, right, and just said. And then we do plus again, so then we're at R times, and now it's down, which is x, y, d, z minus, no, yeah, it's y, d, z minus d, y. Okay, why is this one so... Okay, yeah. And then we're on to the next line, which is times, so now we did d, so now it's dl, which is x minus dx, y dl, and z minus d y. And finally, we're at this one, times this one. And we want to do absolute sign there, and let's see how this looks if I screwed something up. Can't you do it in multi-line? Is that actually the problem we're gonna have? Do I need to do... Yeah, maybe I do. Oh well. And we actually want one sign here as well. Let's see if... Looks rough, but do we want to have an indent here, or do we want to maybe we want to skip, maybe we want to do it like this. This looks so bad. Fuck it. So here's the thing. If you simplify this, maybe I should show it in preview. If you simplify this, or if you substitute L, U, 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 R, etc. to points using the center point's coordinates and the delta, or the distance to its neighboring points, then you can simplify this in a very nice way. You can actually simplify it to this. Like, we could do these calculations for hand, but I put this into Wolfram Alpha and we got this. So that's basically, let's just rewrite that in a little bit of a nicer way. So that's actually equal to yeah, and B is, so it's minus B is the so when I wrote this yesterday I used not the best naming of my variables, but B, A and B is the step distance to the next points. So what do we have? We have B, that's D Y multiplied by D, which is down, so that's D Y. Actually, let's save this one so I don't have to rewrite it. And then we have minus, well, one sec. Did I actually screw this up again? dy, yes I did. No, I did not. It's not dy here, it's y d. So that's, it's a could probably use better naming, but so this is delta y. So we have delta distance in x and y directions. This is the delta distance in y direction, and this is the y position of the down point. Okay, and then we have, spoiler alert, Fabric. Here you can see why we have the 6 in the on the y position. But then again, the step from here to what we're writing now is huge. But okay, let's see here. So dy times, or actually minus plus dy times f is down left, so that's y down left, minus dy, and g is upright, so that's times y upright, and then we have plus 2 times b, which is dy times L, which is left, so y left, and then we have minus 2 times d times y right, plus dy times y up. Okay. So that's the x. Good morning, Mechasonis. And here we have 6 times dx times dy. And then we have the final term, which is 2 times dx. So let's copy this one now. Times y d plus this one times down left minus this one times upright minus this one times y left plus this one times y right minus 2 times this one times y up. And we want to do the absolute of this one, and then we finish off with this one and wonder if I can take this on 2. Let's see how it looks. Preview. Jesus. Okay, that's not pretty at all. So the 6 is there because there is 6 directions. That's a pretty good assumption, I would say, Fabic. Like, okay, so if we simplify this, we get this, and then we can also divide dx on all 3 and dy on all 3, and that's why we get a single x in the end. And when we calculate the y position here, let's see if I remember my math. Isn't it? So when we do the cross product here, and we want to calculate what we have on the y position, isn't it this one multiplied by this one, and this one multiplied by this one? So still a good question why exactly we would get end up at this. But like when we do it, the even more simplified version has it like this. And the step from this to this is pretty straightforward. How can I write this in a better way? Maybe it's not possible. Oh, no, you should have equation. What is it? Oh, here we go. We want to do, double. Let's see how it looks with double dollar sign. I wonder... Ooh, pretty. If you do double dollar sign, can you skip? You cannot. Okay. But you can do it like... are we gonna have to do it like, let's see how it looks. Plus this one, plus this one, and let's see how that looks. Is it not possible to do new line? Fabric, sorry for the distraction, sir, but can you post a link to this GitHub? Would like to read it later. Not specifically to this GitHub issue, it's private, but I can send you the markdown file for it, so you can read it in better text if you want. Okay, let's see what happens if I just want to make this look a little bit prettier for future me. Yeah, I definitely don't want this one. Jesus. Let's see here. Math, LaTeX, new line. Begin get this might be too specific. Johan with vertical vector. What do you need? What do you mean? What do this person want to? no. Do I really need something like this? I probably need to search specifically for GitHub Markdown, but okay, let's do it like this then. So n is equal to yeah, I don't have any problems with sending this one, but hopefully I can make it look a little bit better. Like, this is insane. Math support, do we have any more links? Like any this content is then rendered using highly popular MathJax library. So MathJax new line. Ooh, yes, please. No. And this one didn't work. What the hell? If this one is used, if MathJax is used to render this one, why? Is that because... Oh. Okay. Wonder if we have access to display lines. I don't know, but let's try it. Display lines. Doubt it. Okay, this is unfortunate. So, okay, how can I write this in a nice way? Let's do... So, like if I keep... if I keep them on each on a separate line but with double $sign notation, we're gonna get, it's gonna look a little bit weird. I think the length between them are going to be extremely big, but I wonder if I can we use, so we have a how would I even go about this? I mean, instead of displaying x, y horizontally, having them in a column should reduce the length of the equation. Yeah, that's definitely true. So doing it like this, pretty much. But that would probably be better with single $sign. The thing with single $sign is that we don't get it centered, and that looks like shit as well. Wait. I want to make this one $sign, by the way. Oof. Damn, this looks good. If I could make something similar with this one as well. I wonder if we can have double dollar sign and then single dollar sign. That would be sick. But also extremely weird, yeah. So I guess the best approach for now is... But what the hell is with this distance here? And we went from calculating normals to page CSS. Yes. GitHub Markdown math new line, please. Ooh, maybe. Oh, this would be sick. Please. So that would be a dollar sign aligned, and then we use double backspace, and we need an end aligned as well. So here, begin aligned, and backspace, and let's try it with this one, and we do double dollar sign, but we also do a end aligned. Oof, please work. Do we need to do it? Doubt, but would be so nice if we could write it like this. But we can't. MathJax Markdown, but maybe not GitHub Markdown. Okay. Is this related? Is this related? Yeah, I definitely don't want to spend too much time on this, so maybe just settle for one solution. Weird that this doesn't work though. Oh, one sec. Why doesn't this work? Have I messed up? Or maybe it does. Let's see. Is it because you need to have it like this? Oh, there we go. Yes. So could actually it should still. Okay, fuck it. I guess we're gonna go with this. It hurts me that I might need to settle for this, but whatever. I don't understand why it would be so hard to just add a new line to a mathematical expression in Markdown. Markdown math not working properly. Could this be it? Math. Yes. Okay, we're on. That should be it, right? Or did I misread it? It seems like this one. Okay, we're not getting a new line, but maybe we just need to do. Or is this going to be the same issue as? Mm. Okay. But can we do GitHub markdown new line in code block? Yeah, I'm not sure. Oh well, so when I read through this in the future, normal calculation implementation notes, and I get down to this equation, I'm gonna have to go like this. What the fuck? I wish I could find a way to fix this. If we do math code block, what was the GitHub markdown math new line? What did we have? This one is not working. And it choose this didn't work with the previous way of doing it. Does it work with the new way of doing it? Ooh, it does. Okay, let's see. Let's see if we can fix it. Or it seemed to do, at least. Beautiful. This means that we will soon be able to do something actual productive. Oh yeah, that's because this one needs to be here. Beautiful. Oh, that's probably a FRA ad I haven't seen. I can't even begin to guess how much money they've poured into having this much commercial on Twitch. Okay, but finally here we have it. This is somewhat readable compared to the previous one. So, calculating the normal 4-point P using its connected neighbors left, up, right, and down, left is done with the following calculation, which can be simplified using D, where dx is the horizontal step distance between points and dy is the vertical step distance between points. 2, maybe not the best sentence, but whatever. So here we just take this one, substitute like L for x offsetted by dx, and then we get to this, which we finally simplify one more time to this. But then again, I don't even think this last simplification, now I can remove this as well, I don't think that last simplification is that much better, if I'm going to be honest. So if we take a look at this, we get 2 divisions instead of, like I think delta.x delta.y multiplied by this, and delta.x multiplied by this, and here we have multiplied by delta.x delta.y. There are 2 of them. One is a guy in a music store and the other one is some restaurant thing. The restaurant one I've seen multiple times. Okay, so let's see if we still have the same normals, and hopefully we can leave the GitHub markdown. So this is Unity approach, this is our approach, and you can see we get the normals are a bit like more towards the straight world up in the corners here. And that's because of this thing. So basically, in this solution, if we don't have a point, let's say that we don't have a point left because we're at the end of the vertex or end of the patch, then we replace L with P. And if we replace L with P, that means that we can't simplify it like this anymore, and we get a little bit of a difference, and that difference is why this one doesn't yield the correct normal at the end. So the question is, can you properly replace this side of the calculations with something else? Or like, is there something we can do to fix this? And like, I came to the conclusion that it's pretty much irrelevant. Like, we might, like, it's irrelevant. It's so irrelevant, but still relevant, that I will just put down a to-do and fix edge cases, maybe. Fix normal calculations on edges. is irrelevant now might be relevant in the future, is what I'm trying to say. And we can probably skip this one as well now. And the very cool thing is, actually when I think about it, we're going to clean this up a bit later on. The very cool thing here is, thanks to this simplification, we don't need any information for the points other than the height, which means that we can do this solely from the height map. For Looping Bash, thank you so much for the follow, appreciate it. So my question now is, before we continue, terrain data texture 2D. Do I want to pull this one out from this class, put it into its own class, and add some nice functions, much like this, to be honest? Inbound index, inbounds, x, y, get. So yeah, I think we're gonna do it. And if we pull it out and put it in our own method, we can also decide that, or specify that R is depth, G is something else, B is something else, and so on and so on. I think that is I think we want to do that. And we can pull this out, set terrain data, lerp. Definitely. Let's do it. Actually, before I continue, update this comment so I don't lose this. But this, a very nice surprise that you can use. It's extremely tiny in the default size though, but very nice that you can use pretty much LaTeX syntax for math in this markdown. It's gonna help a lot with future notes. But okay. Terrain base, terrain patch. Terrain data. What is the word for something wrapping around something? Not terrain data wrapper, but terrain data see something. I thought. Let's see if I can find it. Could just name it terrain data as well. Cover wrapper. Fuck, is wrapper actually the best? Maybe it is. But then let's just go with terrain data. So we're gonna add and implement terrain data. Terrain data container. There we go. The first one we're not gonna have as a mono behavior, probably change it in the future. Terrain data container. First of all, it's going to have a private terrain texture 2D. And we're just gonna call it data within here. I think that's a little bit prettier. Public terrain data container. Yeah. It's equal to data. So when we create this one, we set the data. Or that's one way to create it. We're also going to have a public terrain data container int width, int height. Okay. With height. Do we want to save these within? I don't think so. I think data will actually hold it. Or have its own width and height. So we're just going to do this. Oops. This dot data, even though we don't need this. Yeah. With height. Set terrain data. Instantiate. Terrain data, set terrain data. Yeah, this one we want as well. New terrain data, regenerate terrain. Terrain data texture, and yeah, we want to save this. So terrain data container, public void, set Did we actually test what happened with this? If I don't remember, maybe we did. Resolution X. Oh yeah. Never mind. Like if this one is way bigger than the original one, what happened then, and so on. But yeah, we're gonna make this work. So data dot width, data dot height. So when we get a texture to the new terrain data here, we create a temporary render texture that is as big as our previous data texture. In fact, do I want to do this here? Ooh, I don't know. Like, do I actually want to, when we create set terrain data, when we create this from when we use the instantiator or the initializer or constructor method with a texture 2D as an argument, do we actually want to do we want to call this one first and then this one? Maybe that's the better way to do it. So new data. Or is it unreadable if we do this? It's pretty obvious, right? That we use the old data. And then we blit data into temp. And then we do this dot data, this dot data, resolution. It's a little bit unreadable, isn't it? Data, this data. If I rename this one, then we will get this new data. The more I read this word, the less I actually think it exists. What's up, Render Goblin? How's the epic terrain coming along? Extremely slowly. We started off, like, the first hour of this stream was spent on getting math, like to proper write math equations in GitHub Markdown. But now we're moving on to new stuff. So slowly is my answer to that question. Yeah, let's do new data instead. We want to be crystal clear here. It should never be a question of which one is the new, which one is the old. So let's remove all of this. Now, right now we're just doing normal generation. Okay, so when we call this constructor, we're gonna do terrain data container. Is this how you do it? New data. Yeah, it had it correctly. How is it you... Or actually, let's do it like this. Private. Do I want to do public or private first? I don't remember. private void instantiate data width int height. I think this is a little bit nicer to do it. And then we do data is equal to, we just do this basically. Instantiate data with height. And here we do instantiate data new data dot width new data dot height, and then set terrain data new data. Thank you, Render Goblin. Have a great rest of the day. What's up, Cooler SK? How is the quest for grass going? The grass is on hold. Now it's more about the quest for terrain, you know? And it's going pretty good. How are you doing today, Cooler SK? Terrain data container, instantiate data, set terrain data. Okay, something like this. So then we can remove this. I don't know. Nah. And here we do, this is instantiate here, so we do terrain data is equal to new terrain data container, terrain data texture, and then we also do generate. So when we have everything set up, that's when we generate it. Do we want to do this first as well? Nah, it's probably okay. We have get pixel we need to implement. Okay, I guess. Still need to finish my art commission. Alright, good luck with the art commission. I think probably just want to implement very similar methods here. Index. We don't need this one actually. That's true. Inbounds X, inbounds Y. We do want those, but here we do data.width. And here we do data.height, get vector, and here we do, we're gonna do, yeah. I think I want to do it like this. Get value int X, int Y, int Z, but Z, I wonder if I want to go with C for channel instead. And what we do here is we just return data.getPixel X, Y, which returns a color, and then we do C. Can we do it like that? And we want to change this to float, of course. I know it's unsafe, or we don't check against these, because I don't think we want to do that too often. But we have get value with a C. What I want to add later on is I want to add a private float get height int X in what the hell? int x, int y, and what we return here is get value x, y, and then we know which channel it is. So for height, we're gonna go with 0. So this one keeps track of that, and this is how we define it, while every outside class just calls get height, or I don't know, maybe it's in the future get navigation value, int x, int y, and this one is get value x, y, 1 maybe, but we don't know. So for now, let's comment this one out, because we're only working with height value right now. So here we do terrain data dot get height. Or actually, do we want to get? Do we just want to name it height? Fuck yeah, we do. So get height ij. Yeah, we want to change these to public, all of them. Maybe not inbounds actually, but these. And I wonder if it's cleaner to just do value and height. So let's do value, height. Looks pretty clean, right? And then again, I wonder if height range is something we want to do. Height range, maybe we want to add it to terrain data. So terrain data container, we do terrain data container int with height, new data. Public terrain data container. And then we do range, height, width, height. Fuck, how is it in C#? I do want to call this constructor. Call other constructor from constructor C#. Is it possible? Ooh. So we want to do this with height, and then we also do this dot height range is equal to height range. This yeah, something like this. So then we have the height range here as well, and we want to do height, public float height, and public float raw height. So raw height, a value between 0 and 1, that's like the data we have in the texture. Height, also take the height range into account. It's more of a multiplier. The question is, do I want it in terrain data container or not? It might be cleaner to have it here, because then we can just do in terrain patch when we generate the patch. We don't do height range lerp blah 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 blah. We just do terrain height, terrain data height. Looks a bit nicer. The constructor not as nice, but whatever. So then we remove height range from here. Already done. Okay, so next question. Is it weird to fetch the normal from terrain data? Like if we create a method in terrain data container that has like calculate normal from height map. It's not that weird, right? But then again, then a height map needs to know triangle neighbors. Up, down, right, left, up, right, down, left. And if we're gonna calculate the normal within terrain data container, it's going to be the communication with neighbor terrain patches is going to be ugly, so we might as well do it here, but we might clean it up now that we have a terrain data container. But it would be so much nicer if we could keep this in terrain data container, but that's not going to be the case. Now we need to keep it here for the communication to happen properly. This looks nice. It's also it feels like we're gonna have to do calculate normals. Can't decide if it's nice to have this terrain data container like this. Maybe it is. But it feels like I want to have a get height value here as well, I think. You could also it's the communication between patches which we're going to have, or that we need to have. Or for now it's just the communication between height data between patches. I'm just wondering if there's a nice way to do this, or if we're just gonna rush it. So when we create the patches, let's see here. It feels like generate here. Here we generate the different patches here, and then we instantiate a terrain patch. Might make this a little bit cleaner as well, but like when we instantiate here, let's say that we add the proper height to it, then it feels like we need to do, when we add the next terrain patch later on, we need to add it as a neighbor to the previous one and to this one. Like we need to also set up the connection between the terrain patches, and it's first when we have that in place that we can actually calculate the normals. So it feels like we're gonna have to do this in different batches pretty much. So first instantiate terrain patch. If we have some previous instantiated terrain patches, we set up the neighbor links. It's rough. Fabric, you can remove the terrain patch variable and add component so we do like this. Yeah, maybe. Yeah, that's a little bit better. Thank you, appreciate it. Maybe you could also do, or could you parent is equal to, is that possible? Parent is equal to transform. Oh yeah, that's true. That's a transform. But can we do transform.parent is equal to transform. Nah, fuck it. But, so it's basically going to be this. We could do it in with two approaches. We could do one, instantiate patches. Add or set up neighbors to previous patches. There's so many ways we can do this too. But one sec. I think I want to do it like this. So when we instantiate a patch, we're going to calculate the normal for we're going to calculate all the normals. And I think we're also going to implement a recalculate edge normals, maybe. So when we define a neighbor to a terrain patch, we just update the normals on that edge. But we might as well also do it a little bit easier. So here it's but still add neighbors to previously instantiated terrain patches, and then we're gonna have to, for each terrain patch, calculate normals. Like we can do it in one for loop, or we can do it in two for loops. Would be nice if the normals could handle themselves, so to speak. And like if we do, like look how nice this would look if we had set terrain data, instantiate terrain data. If we had something like public vector3 get normals based on height. Data. Or just get height. Get normals based on normals from height, whatever. And we just hide all of this. I also wonder if delta what happens if we replace this one with 1? Am I misremembering stuff, or we didn't have these previously, did we? Extremely weird. Yeah, we didn't have these gaps previously. Have I screwed something up here? Terrain data texture, yes, because the one we send in here is... Let's see here. Garden 64 times 64, and we define... it should be okay. Oh, no. 64 times 64, and we subdivide by 2. No, I think now when we change to this, we screwed it up a bit. So previously we did... Let's see here. We did set terrain here. We based it on resolution, X, Y. So instead, if we do this, let's see. If we do new terrain data container, if we instead do this, let's see. Terrain data container, and we set the size here to be resolution.x, resolution.y, height range. What's up, Dev Spires? Thank you so much for the raid. Appreciate it. And have a good lunch break. So if we do this instead, and then we call terrain data.set terrain data texture, then we should get a similar result to what we previously had. Yeah. So with the new implementation way here, or like previously, we created the terrain data texture to be resolution XY of the terrain patch, but with the new changes we based the... So this means that the terrain data is actually only 32 times 32 pixels, which means... What's up, modding Minecraft? Still terrain? Fuck yes, still terrain. And I reckon we're gonna do terrain April out, I suppose. I wonder though... It's just feels weird that this is perfectly April 2024. Let's keep the year unspecified. A little bit of a lean way, room for lean way, or whatever it's called. I find it extremely weird that this is repeatable. It makes me want to test this one. Okay, so what happens... No. Okay, it's not weird that it's repeatable. So, with the new solution, if we do it like this, what happens is that we call this one... So we set terrain data. First of all, we call this one. So width, height is the... texture width and height, which is 64. Then, or actually no, or actually yes. I think it will become extremely clear if we do this. Like, I do want each patch to have the same texture right now. I just want to know why. Yeah, exactly. So when we do it like this, we only get 1/4 of the texture, and that's because Fabric, you always will get the same values because you're iterating from 0 to width, so X and Z is the same. Yes, that's exactly what I want. So right now, like, the result we're seeing here, let's see. Yeah, so this result is what I want to see. So it's basically we have the same terrain texture for each patch right now. In the future they will have different terrain textures. What boggled my mind was, since we moved a lot of the logic from terrain patch to terrain patch container, we no longer had connected corners, and that had to do with a mismatch of terrain texture basically. So if we just do it if we take this one, then we base the terrain data on the terrain data texture, which is wrong. So basically what we want to do is we want to disable for the possibility to, we don't want a constructor purely with new data. So instead we want set terrain data, we want this. Let's see. And then we want, yeah, so we basically want this. Int width, int height, range, add texture to the new data. It's very important that width and height are specifically designed and not based on this new data. It's always up to this method to scale whatever this data is down to what it should be, explicitly specified. So here we want to do this. Like, the reason for us wanting to have different textures per patch is that I'm not entirely sure how comfortable I am with having like a 8K texture specifying the terrain height over multiple terrain patches. I'm more okay with having like a set of 256 times 256 textures defining multiple terrain patches, one each. But we will see. I'm prone to going back and forth on issues, you know. Okay, so get normals from height. This was what we were supposed to implement. So instead of doing this, we're gonna redo this, but using the height values instead. So my question is, if we use height values, like, then the delta x and delta y is going to be 1. So will we get these same normals if we just do this? Hopefully, like mathematically, we should, right? But we don't. I find it extremely weird. So if we substitute delta x and y with 1, oh yeah, I fucked up. So we remove this one, we remove this one, and we remove this one. What's up, Peach? Long time no see. What's new? We have moved on from grass to terrain. That's pretty much what's new. Fabic, your solution should be better for terrain modification. You won't have to read 8K texture. Yeah, that's true. I agree with that one. Okay, so C. This is very weird. So if we do times... what was it? Let's see. This is what I don't understand. So delta x and delta y. Dimension divided by resolution. I don't understand. So let's say that we would do this with a texture instead. Wouldn't we get dimension divided by This delta value seems to affect the end result more than I give it credit for. So the question is, does it also have to do with this simplification or not? I don't get it. I thought we should be able to dimension resolution. Right now we actually, I'm not entirely sure we want +1 here anymore. I think this is the correct, but let's go through it real quick. So resolution subdivided, we take resolution divided by subdivision. We also do the same with dimension. Dimension subdivided delta. Do we use this one still? Yeah, we do. Yeah. But let's see, dimension subdivided and resolution subdivided. Okay, good. Subdivision divided by subdivision, resolution divided by subdivision. Okay, so in our case we have 160, 160, or we have 64. Yeah, 160 and 64. So in our case, what do we get? Calculator. We get 60 times 2, that's 80. And we get 64, or not times 2, but divided by 2, 32. So we get 80 divided by 32. That's our delta, right? Within terrain patch. So that's our delta in both directions, I think. 32 or 2.5. So that is the distance that is the distance between one vertex to the next one. I just find it extremely weird. So 2.5. I find it very weird that this affects the normal in such a big way as it actually does. So I just want to try something. If we make that value if we explicitly make it so that delta is equal to 1, 1 by doing dimension, resolution and dimension being the same thing, I guess. Yeah, 160, 160. So now if we do, so this is Unity normals. Our normals similar except for the edges. So now we have resolution and dimension is specified in such a way that this one is 1. So now if we remove this one, we shouldn't see a difference, or should we? Yeah, exactly. Okay. Very interesting. Because what I want to do is I want to calculate the normal from the height texture, but this simplification won't hold unless delta is equal to 1, 1. That's the current problem we have. We could calculate it from the height and then scale it with this, with the delta. But like, I would like to avoid that, but to be able to avoid that I need to actually understand exactly why this one is affecting it. So it's pretty clear that this one affects it, but I don't just like, I don't see why it should. Like, if delta is the same, the delta is the same for all of these. Like, I get it that it's like a weighted, you want to weight how much the neighbors, how did they calculate delta in that stack overthrow? That's a good question. Don't I have it here? We do. I don't think they. Yeah, where AX, AY is the constant grid step on the XY axis respectively. So with like I'm just they used it because they only had 6.0, so it looks like they didn't need it. Not entirely sure I understand that. Oh yeah, for y value you have 6.0 times delta x done. Yeah, but that's just because they have simplified their... they divide all of these three with delta y. They pretty much do... They divide all of these values with this one. Just to get rid of this one, like, it's a last simplification step. So writing this is pretty much the same as writing, let's see. Oh yeah. But like, I want to understand why this delta affects the normal in such a way that it does when we don't have a delta of 1, 1. I just find it weird. So with this one, delta is equal to 1, 1, which means that we can remove this, this, and this, or just replace it with 1. And the normals we get are correct. But if we define the garden as, if dimension or resolution is if dimension and resolution are not equal to each other, then we don't get the correct result. And I don't like, For each vertex, we just read the height value from the texture, ij. Time for experiment with one small patch and draw gizmo for each normal and play with the delta and see what kind of effect it has. You're probably true. Or you're probably correct, I mean. The reason why I'm asking these questions are because I want to do all of this only using the height texture. And if we're using a height texture, like if that's our sole base for the normals, then we have a delta of 1, 1. If you assume that delta x is equal to delta y, for me the PB is that y, the problem is that y is delta to the power of 2. So even if you divide everything by delta, y remains dependent of delta. No. We like the simplification. When we have 6 only here on y is because we divide with both of these on all 3 elements. The problem now is that we assume that delta y is 1 and delta x is 1, and if we substitute that, so we get 1 here, 1 times 1 and 1, so then we just remove the delta, the delta terms, and if we do that we get the correct normals, but only it's a weird way to put it, but like I don't understand why the length. But actually I probably do. I think I do. Yes, so what we want to do if we... Yes, okay. So this affects the end result because... I think, okay. Because when we rewrite, or it does because we have 2 vectors, that is UR and DL, so we have upright and down left. Those 2 vectors has a different length. So every other vector, so left, up, right, and down, they all have a length of, or actually, so left and right has a length of dx, up and down has a length of dy, and down left and up right, they actually have a length of, what is it, dx to the power of 2 plus dy to the power of 2 and square root on that. So what we could do instead is we write these, if we write this, if we write this equation, like we simplify it like we have here, but instead of having variable dx and dy, we do it with dx is equal to dy, and I think we will get a different result here, I think. Or I might just be entirely lost again. But I want to check this. Would normalizing those vectors help? I don't know. I do so want to try this, but I know that it's gonna take so much time writing it in a Wolfram Alpha way. Let's see what we have. So it's this one, right? Okay, so now we're back here where we were yesterday. But let's see here. So it's basically, let's do dx. This one we want to replace with 1. And dy we want to replace with 1. Oops. And let's see here. L we just want to replace with L. Oops. U we want to replace with U. R we want to replace with R. What do we have left? D we want to replace with D. And then we have DL and UR. Wolfram Alpha unfortunately didn't work that good with variables with 2, consisting of 2 characters, so we're gonna rename this one. So upright is G and down left is F. Are we okay with that? Okay, so what we assume here, and we want to replace times with okay, so this is the same simplification, but or the same math equation. It's just that we now have the assumption that the delta, or the distance between the points, is always 1 in either up or down, which means that we get it's a little bit longer to the diagonal points, right? So let's see what this simplifies to. Like, this is my best bet. I'm not entirely sure though. And I wonder if we need to simplify it like this. Math indeed. Okay, there we go. Let's see. Let's see. I agree, Fabic. Okay, results. So now we have something like, let's copy this one, plain text. But then again, like, why would this work? I don't know. So now we get something easy. Is this actually... two times left minus right plus up minus, what was G? It was down left. No, up right, down left, minus D. It's the exact same, right? Except for, it's actually the exact same. Yeah. Wait. It's exactly the same. Yeah, except for that we just removed the deltas. Jesus. I thought I understood it, but I didn't. Like, it all comes down to okay, let's draw the gizmos, and we want to be able to change the delta here. So let's do let's do instantiate. Let's do it like this. Float. Let's go delta multiplier. Delta multiplier is equal to 1.0f. And then we do delta multiplier. And then we do generate public void on draw. Actually, it's private. It doesn't really matter. On draw gizmos. And what we do here is for each vector3 normal in get normals, or calculate normals connected. Oh no, do we need to send in the vertices as well? Yes, okay. So let's do, let's vertices. And then I want to define I think we can do serialize field test float. This one we send into our gizmo when we draw these. And for each normal here we do gizmos.draw line from to we need for each let's just do draw line from vertices I to vertices I plus normals I. Should be. So each on draw gizmos we calculate the normals again with this test float as a multiplier. Test float just multiplies the calculated delta multiplier we have here. Or test float just calculates or works as a delta multiplier here. Delta right now is 1, 1. And that should be about it. Let's see what we get. I thought. Test float 0. Yeah, we want 1. Okay, so my question now before we continue is why don't we get this for all the vertices? Okay, we get it for all vertices, but we don't get the offset. Okay. Hell yeah. Okay, so we want to do vertices I, so we also want transform dot position, I think it is, plus, and then transform dot position. This should be it. Or is it? No, it shouldn't be. Let's see here. Vertices. Yes, it should be. It should be. And has float is 0. There we go. Finally. And very nice. The higher multiplier we have, the more straight up we get, right? Okay, I'm starting to think, or actually, let's see. That doesn't make, does it? Yeah, okay, I'm starting to think that this delta here is pretty much is it, do we need it, or like, yeah, do we need it? Do we need the actual value to it? Because we need to figure out how much the diagonal, the height of the diagonal ones will affect it compared to, I don't get it. That should work with 1 as well. Right? I need some coffee. Be right back. Okay, back. Looking forward to getting to the bottom of this. If you go over 1, does it stay up or moves the other way around? No. Like, the higher it is, the more we converge towards up, and then we just... If it's extremely high, it just points straight upwards. Like, I want to solve, or I want to understand this, because I think I want to have this in... I think I want to like base the normal purely on the height map, and if we do it purely on the height map, like the dimension divided by resolution should be 1. Or actually, or 1 divided by resolution dimension. I don't understand this. Yeah, this is... Yes. I know that we could continue on without actually fully understand this, but it would always be in the back of my head, annoying me. Like, why? So delta is pretty much we can rename it to, it's basically, so the dimension is in real world distances, resolution is number of vertices. So it's, yeah, it's the length, the real, like the world units between vertices. Units between vertices, and this is constant for all of them in X and Y. like, so let's assume that we move on to doing this purely from the height map texture. What do we replace this with? So do we do dimension divided by... Do we do dimension as 1 and resolution equal to the number of pixels? Is that what we are gonna do? Like, we have a special case where delta y and delta x... Ooh! Johan, you might not have been too far off. So a special case is when delta y and delta x is the same. But that's not always going to be the case. We need to keep the... We needed to keep the relationship in size between these two. So... Fuck. Or is that it? So if we were working with purely with only the height texture, our delta could probably look something like 1.0f divided by resolution. Let's do vector 2.1 then. Will we get the same? Will we get the correct result here, or? No. Resolution times dimension divided by pixels. Harukanen, so relatable. Fabric, resolution times dimension divided by pixels. But for a texture, the texture is just for the patch. So when we're in the patch, everything is related to the patch in question. So this is the dimension for the patch, the resolution for the patch, and the texture is for the patch. Like, we could do all of these calculations for the texture, and then we just want to scale it, but it's fucking weird. That we need to scale it. So what I'm saying, the calculation for this normal in the texture, if we do it purely on the texture, it's going to look something like this. Vector 3, can't even write anymore. Vector 3 normal is equal to, now we take this, we do this, and we remove the delta from everything. So this is gonna be how it looks when we do it purely with the height texture. And then before we add it to this one, we want to do normal index is equal to, let's see here, vector 3, or actually normal dot scale one, or actually delta dot y delta x times delta dot y and delta dot x, and then normalized. Oh yeah. Can we do new vector 3? But this just returns. Okay. Okay, so if we would do this in a texture, this is the calculation we would do in texture. When we get out, we will do the scaling and then we will place it. And like, I'm trying to get to the, like, why is this needed? Chablis, what even is that? I don't know how to comment. I don't know. Chablis. Oh, okay, I get it. So it was the FRA, yeah, the FRA commercial on the restaurant. Okay, so let's see if this works. Yeah, okay, so that works. So this is what we're gonna do. Yeah, white wine is probably not my favorite. Okay, so why, like, this is probably how we're gonna do it in the end, but like, why do we need to scale the normal with the distance? I don't know. Or do I don't know. Like if we take a look at this, we're only using the values from the... Oh, one sec. It shouldn't have to do with the actual height value. Or could it? Oh, how can I quickly test this? Okay, so now we're fetching the height, like we're getting the height values from the texture instead of what the height of the vertices actually are. And this should yield the same result when we do the normal calculation. Okay. Intrigued. Raw height. Have I screwed this up? Value XY0. Did I screw it up so badly when I changed it to float instead of vectors. If we do raw height, let's just do okay. Raw height, we just return a value between 0 and 1, which results in us getting a very... Whoa, 1 sec. Now raw height just returns the height. So that's what we get here, up, down, right, left. And then we just calculate it like this without the dimension. And yeah, we get the correct values because delta is 1, 1. Right. Yeah. But if we do 80 and 80, we get stronger normals. Okay. But my question is, terrain data container, if we move back here, so now raw height just reads the value from the height map texture and returns it. We do the same calculations here. We get very weak normals. So my question is, do we need to scale it with delta? But delta being but delta being 1 divided by resolution. Not too sure. Cooler SK, are you using epic algorithms of Mega Brain of Versidium? No, I don't think so, no. Not yet, we're gonna explore it later on. First, I fully want to understand this, and it's something, like, I have some type of blind spot here. No, not yet Cooler SK, but we're probably going to use some of his optimizations later down the road. We'll see. But for this problem, it feels like I have one little speck of a blind spot. Like there's some information I'm missing here. And if I can just gather that one, everything will make sense. Or that's what I hope at least. No, Cooler SK, sorry, I did not yet. Gonna try and get to it today or tomorrow. Am I? Yeah, I'm starting to think that this... I'm starting to think that I am just overseeing how, like, the distance to the next points, how much that weights the normal. Cooler SK, by the way, you should go into his community tab on the channel. People vote there for the focus on the next topic he researches. Oh, very nice, yeah. I might do that. So, it's basically, let's see here, raw height. We want to do height here, I think. Or actually, raw height. And distance to, if the height is between values 0 and 1 and the distance to the next vertices are 1 divided by resolution. What kind of result do we get? Yeah, we do get so I want to check. So basically previously we did something like this. Let's see. Let's uncomment this one, and here we do dimension, and then we use height here instead. I want to make this make sense. We calculate the normal, then we use the delta to scale it, and on it goes. And then we do 1 here. We do get the correct normals, right? Yeah, we do. Okay, and then we go to 1 here. And the higher the test float value goes, the more our normals points straight up, and that's because delta, yeah, the distance to the other points becomes bigger, i.e. the other points affect the normal of the point less. So the higher the value we have, the more upwards it points. The smaller the value we have, the more the neighboring points affect it. So if we have if we would have a very small value, we would probably get the tangent, or the tangent, I think. It's interesting. So for this point, so what would happen if we do raw height again? And we do So if we do raw height and we don't scale it, then it's the same as doing... Oh, actually we want to scale it by 1. It doesn't really matter. So if we do raw height, so between 0 and 1, and we don't do any scaling, then it's like height is 0 to 1 and the distance to the next vertices are 1. Still not entirely sure why this wouldn't give the correct result actually. Like, we're getting 2 strong normals here, sure. But by how much? Is it 0.5? Or no, 1, 2, 3, 4, 5. By how much? Yeah, maybe it just everything probably makes perfect sense. It's just me who's being dumb. But delta is probably, yeah, like, it affects this a lot because it's basically, it weights the normal. Math is hard indeed. This is probably a variable we want to save. Yeah, I'm still trying, like, make this make sense, but I think I've accepted that, like, pretty much distance between vertices, we need this one to properly weight the normal. So if this one is extremely big, i.e. there's a big distance between neighboring vertices, then those vertices affect the end normal less. Yeah, because the slope... Yeah, the closer they are together, the bigger the slope, or the bigger the slope. The further away they are from each other, the smaller the slope, and the slope is going to affect the normal. Does it make sense? I think it does. But like... So if one would do, like, generate a normal texture from a height map, would one assume that the height is between 0 and 1 and the delta is between 0 and 1, and work from there? So if we did raw height, I know what, let's do implementation notes. Yeah. Calculated. Calculation and distance between points. Yeah, I'm probably gonna understand that tomorrow. But, so let's say that I do want to move... let's clean this one up using the new terrain data. But then again... So let's do... Like, I wonder if... Like, what I want to know is, okay, can we do this? Let's see. Raw height. So this is between 0 and 1. We calculate the normal using that one. What, we got the wrong result. Or we get a more washed out result, right? Yeah, definitely. Compared to this one. Way more washed out. So I wonder if we can do... Here we get a raw height value, and here we get a raw height value. I wonder if we can do... height range. Raw height, height. Beautiful. So I wonder if we can do terrain data dot height range dot inverse lerp. Or actually it's just lerp, I think. But it's weird. Yeah, that doesn't give us the correct result. Yeah, there's one bit of knowledge I'm missing / not understanding. But But this is probably the approach we're gonna have to take on calculating the normal. So this is the exact same way as the Unity implementation does it. And it's mostly okay, I get it. It makes sense. But like, my next question is, how could one, and is it possible to use this algorithm to calculate the normal, but we only have the, like, we only have a texture, a height map, and we want to calculate the normals from that one. So we do that, and then we take that normal calculation result we get and we scale it out to based on real world parameters or variables. Like, could we do these calculations where all of these are raw height? We calculate this and then we scale it based on dimension and the real height. It was something similar I tried just now, but didn't get the correct result. Or did I forget to... Nah, it shouldn't matter. Medic and Nikki, by the way, thank you so much for the follow. Appreciate it. Appreciate that you enjoy this enough to follow. It has been a battle against understanding today. It's so damn unsatisfying as well to not have, I guess, a few things has become clearer, but to not arrive at like a total understanding, it just annoys me a bit. Yeah, I'm gonna see if I can make sense of this off stream, because unfortunately I have to run now. But independent on if I can make sense of it or not, this evening I'm going to continue tomorrow. So we're gonna go with this solution. We're gonna notify that we need to work with this dimension resolution and the real height for now. And we're gonna see if we can implement like calculating the normals with the help of close by terrains. But that's for tomorrow. Because yes, unfortunately I need to run now. But we'll continue tomorrow, and thank you so much everybody for sticking with me today as well. Hopefully we can make some more progress tomorrow. And as always, have a great rest of the day. Peace.